to look at is there's 25 minutes for 20 questions. So you get just a little bit more than a minute per question. And pace is very important. I don't know how you did on your PSATs, but I'm guessing most students run out of time before they run out of questions.
Yeah.
And there's a golden rule that applies to SAT or ACT. And that is never, ever leave a question unanswered. If you run out of time and you have 10 questions that haven't been answered, then you have not managed your time well. First of all, they're going to give you a 5-minute bell. So they'll tell you when 5 minutes are up on any particular section. And that's the 5 minutes where you want to go through and make sure you've answered everything, even if it's with a guess. Because a guess has, on the math, 20% chance of being correct. So you just don't want to leave anything unanswered.
Okay.
Now, each math section, I believe, begins with these pictures, these geometric figures, and the important formulas that you need to know, like the area of a circle, the circumference of a circle, the area of a rectangle, the area of a triangle. You should actually know all of those. If you don't, review them, because you do not want to have to go back to this reference when you're looking at a problem. It slows you down immensely. So any of these that you don't know, including the bottom row, the top row is absolutely vital that you know those. Okay?
Yeah.
The bottom row is three-dimensional geometry. You might not remember those. So if you have to go back and review the 3D, in other words, volumes, then that's okay. But this first row, you should never have to look up what the area of a circle is or the circumference of a circle. That's something that you should memorize and never forget your whole life. And then notice there's 3 sentences underneath, give you the total degrees in a circle, total radians, and the sum of the angles of a triangle. So there's good stuff in this section at the top here. All right, now, one thing about the math is that's different than every other section on the SAT is that it goes from easy to medium to hard.
Mm-hmm.
So, and one of the most important rules in taking this test, other than, never leave a question blank, is do the easy problems first. All of them. In other words, the first 4 or 5 of these questions are going to be easy problems. So do all of those, and then go to the next math section that you can and do all of those. So in other words, make sure that at a minimum you answer all of the easy questions. At no way do you want to get through the test and not have answered the easy questions. So let's look at number 1. If you can't read these, I can enlarge this a little bit. So if you can tell me the answer, we'll just go straight to the next problem. If you're having difficulties or have to guess, then I'll go through the solution.
Okay. Wait, so it equals 3? Okay, so
You should, incidentally, just for reference, since it's the first time we've done this, you should have a pencil and paper in front of you and a calculator, because we are in the calculator section. So you can use a calculator in this section.
Okay.
Whatever calculator you're going to use on the SAT, and there's only certain ones you can use. You can't use any. What kind of calculator do you have, Haley?
A TI-83.
They'll let you use that one. That's what you should have in front of you every time we do a session here.
Okay.
Because that's what you'll use when you take the test. Some of them they don't let you use, like the TI Inspire CAS. They will not let you use.
Isn't it? Wait, never mind. Yeah, isn't it D?
Good. In other words, here's what we have. X minus 1 over 3 equals, well, K is 3, so I do that. Next step, I multiply both sides by 3. That turns that into 9. Next step, I add 1 to both sides, and I've got that.
Okay.
Number 2. Looks like it might be a little hard if you haven't had imaginary numbers, but it's actually very simple. Okay? You don't even need to know that part. Forget that part.
Okay.
You're adding two things here. What would your first guess be as to how you should do this? How should you add those two things?
You do the you do 3i
The real
plus
part
9i?
first.
Yeah.
What's that equal to?
Wait, what? Sorry.
What's 7 plus a minus 8?
-1.
Okay. And now you do the imaginary part. So what's 3i plus 9i?
12.
And you need the sign. It's plus 12i. Now that's what we're going to look for, because that's the answer. And yes, it's right there. Answer A. If you don't see an answer on there after you do the problem, then you've made a mistake. And you have to go back and kind of refigure how to do that problem. Okay? I tell people that there's basically 3 ways to do a problem on the SAT. There's the algebraic solution, which we just did on number 2 and number 1. Then there's the what I call back solving, where you just go through each answer and you see if it's correct, which is a very valuable technique. And then there's the third technique, which I call pick numbers and then back solve. And we'll see problems like that. In fact, let's look at the next one. Here, you know what? Here, let me blow this up just a little bit. That's hard for me to even read. I don't know if you're seeing it the same size or not, but there we go.
Okay.
So we're doing number 3. Go ahead and read it. Don't make the mistake of assuming that the bigger paragraphs are harder problems. They are not. And in fact, it's usually the other way around. Look at 4 for the moment. Look at how many sentences are in 4. That's an easy problem. So is 3.
Okay.
So
do I read it out loud?
Absolutely no relationship between the number of sentences and the difficulty of the problem. So the very first thing you really have to figure out is, what are the easy problems? What are the medium problems? What are the hard problems? And by that I mean, when you go through the test the first time, you're going to do the easy problems. If you run into a medium problem that you cannot do, mark it with an M. When you run into a hard problem that you cannot do, mark it with an H. And then the second time through, work on the M's. If you still have time, third time through, work on the H's. But most likely, you'll finish the easy and the mediums, and you'll be left guessing at the hards. That's fine. You can get a really good score on this test doing that, as long as you get all of the easies and the mediums correct. You could guess on every single hard one, and it wouldn't hurt you that much. Okay?
Okay.
So, what do you think the answer on 3 is?
Would it be 5m plus 4p? Wait.
Yep.
Okay.
When you get it, I'm going to go, you know what? I'm going to stop for a moment, because this is actually an excellent problem to illustrate the third technique. So let's use it for that. This problem was easy enough to do that you didn't have to use this technique. There were only 2 variables, p and m, but sometimes they'll give you a problem that's got like 3 variables, and it'll require multiplication and division. And those can be very hard to understand and figure out what the correct answer is. But there's one technique that never fails, and that's called picking numbers and then back solving.
Okay.
Now, what kind of problems do we want to use this technique on? Anything that's got variables in the problem and the same variables in all 4 answers. So get in the habit of looking at your answers when you look at a problem. If you see 2 variables in the problem and every answer has 2 variables, it is a great problem to pick numbers. What they're saying basically is that m and p can be any number you want. Okay? Now, the one rule that I like to tell people is don't pick 0 and 1. You want to pick small numbers for sure, but stay away from 0 and 1. So tell me what I should pick for m. Remember,
Like just
small
like a
whole numbers.
normal, like a 10.
Small whole numbers.
Oh, small 6.
How about 2?
Okay.
The only ones you don't want to pick are 0 and 1. And there's an advantage in the smaller the number is, the easier the problem is going to be. So 2 is much better than 6 or 10. Okay? Now give me a p that is not the same as m.
4.
Okay? Now, read the problem and tell me how many messages they're going to create using those 2 numbers. How many will Tyrone create?
2. Oh, wait, no, 4.
Over 5 hours, or excuse me, I meant Armand. I want to start at the top. My mistake. How many will Armand create?
2.
That's 2 per hour.
Wait. Why did he do 2 times 5?
That's exactly it. He'll do 10.
Okay.
Right? How many will Tyrone create?
8.
No.
Oh, wait, 16.
P is 4. The hours are 4. What's 4 times 4?
16.
Okay. So how many do they both create?
26.
Okay. Now, that's the answer for these 2 numbers. So all we have to do is find one of the 4 answers that's equal to 26, given these 2 numbers. Well, how about A? What's that equal to?
9 MP.
Give me a number. M is 2, P is 4.
Wait,
Use your calculator. You're going to fill in 2 for M and 4 for P on every one of these answers. And as soon as we find 26, that's our answer.
72.
Okay, so that's not right. How about the next one, B?
2 times.
You can just tell me yes or no even.
No.
Next one?
10 plus. Yes.
You see how this works?
Mm-hmm.
And I could have picked an M of 3 and a P of 5. And it wouldn't have given me 26. It would have given me a different number, but it would have still been C.
Okay.
So we didn't have to know the formula on how to do it. Intuitively, when you pick these numbers, you're going to know how to do it. You're going to know that if M is 2, then 2 text messages each hour, make sure you read every word, for 5 hours is 10 texts.
Okay.
And so even though you didn't need that technique for this, that was a lot of wasted time and effort. In other words, you were able to get the fact that it was C all on your own by basically using the algebraic method. And that's what you should use. But if you find one that's got 3 or 4 variables, it's going to be much harder to do that way. Then picking numbers, if your life depended on it, you'd pick numbers every time because you can't get it wrong that way.
Mm-hmm.
All right, let me scroll down here to number 4. Go ahead and read 4.
Wait, hold on.
Now, even though this has a lot of sentences in it, it's actually pretty easy. You just have to comprehend what you're reading. Read each answer. That might help a little bit. Could C be an answer?
No.
No, some of these don't make any sense at all because it's too high a rate. Nobody repairs phones 108 per hour. So we don't even need that one.
Would we be?
Yes.
Okay.
In other words, B means that D, as in David, is 0, right?
Mm-hmm.
Because when you start the week, there's 0 days that she's worked. So if you make D 0, P equals 108, well, that's the number of phones she starts with each week to fix. Good. You've gotten all of these. Okay. And the degree of difficulty goes up, but just marginally. These next 3 problems here are actually pretty easy. You just have to know the technique.
Okay.
So, number 5. What's our first step gonna be?
Getting all the ones that are
How about
same.
remove the parentheses?
Okay.
In other words, we cannot combine like terms until we get rid of the parentheses. Remember that if you're dealing with an expression, which is what this is, you want to get rid of the parentheses. If you're dealing with an equation, you want to get rid of the parentheses and the denominators and the exponents. So you kind of have to chop it down. And the biggest difficulty here is this negative sign, because that negative sign has to be applied to every term that's in the parentheses on the right. all of this is being subtracted from the first part. So tell me how to rewrite this thing with no parentheses. Now you can always get rid of leading parentheses. Those don't ever matter in the first place. They're merely put there conceptually. But you can remove them by just removing them. So remove the leading parentheses and remove the second parentheses and tell me what to write.
I just did everything the same except I put the plus sign.
Hold on.
Instead of the
read it to me.
x squared y minus 3y squared plus 5xy squared plus 3xy squared.
Hold on, what happened to this term?
Wouldn't you, because if you put the
Let's put it in there and then we'll simplify it after we put it in there.
Okay.
Now, the minus and the minus merely become a plus.
Okay.
So that's x squared y. And now that minus has to be applied to that term. So what does that term become?
Negative 3xy.
Yes. Minus 3xy squared. And that negative sign has to be applied to that term. So what does the last term become?
Plus 3y squared.
Yeah. And that's the only hard part of this problem, is making sure that you apply that minus sign to all terms that are in the parentheses. That's why removing the parentheses isn't so easy there. If that was a plus instead of subtraction, then I could just remove all the parentheses with no consequences. Just remove them. But when that is a negative sign, when subtraction is going on, you have to apply it to every term in the parentheses on the right. Okay? Now, let's simplify. Always start on the left and work your way right. So how many of those do we have in total?
2.
So that's 2x squared y. And we get rid of that one, and we get rid of that one. How many of those do we have in total?
1. 2.
What is their total?
0.
Okay, so we have none of those. How many of these do we have in total?
2.
Plus 2 or minus 2?
Plus.
And I have to use it. I can't just write 2xy squared. In other words, this is a polynomial. I need the signs in between terms. The only sign I don't need is the leading one. Okay? So sometimes you can not write a plus sign, but if it's part of a polynomial, you have to write it. Okay? In other words, it would make no sense to write this like this. If I wrote it the way you told me to write it, that's what I would have written. That's not an answer. That doesn't have any meaning.
Okay.
Okay? And that's answer C. All right. Got time for one more, I think. Number 6. Go ahead and read it. Again, be aware that you're in the easy to medium section. So you wouldn't expect this to be super hard. And that's important. It's important how you judge a problem to be, because your very first task is to determine whether it's easy, medium, or hard. If it's easy, you're going to work on it. If it's medium, maybe. If it's hard, we might put it off until the end, until our second go through.
Okay. use the model to estimate the height age of a boy into the inches. I'm confused. Hold on.
Well, let me give you a hint. This is the equation of a linear equation. That's slope, which means rate of change. That's the y-intercept. And you don't really care about that in this problem. What are they asking for? They're asking for the rate of change, right?
Yeah.
Well, what's the rate of change? What's the slope of that equation?
3.
Yep. But what you have to recognize is that that's y equal mx plus b, with that being the rate of change. Now, let's say you didn't know any of that, and you didn't know how to do it. Well, you can figure out how to do it. In other words, between the age of 2 and 5. So what's the height of the boy when he's 2? Where A is the boy's age.
So
3 times 2.
6.
Well, plus 28.6.
6 plus 28.
So that's 34.6.
Mm-hmm.
Now they want to know each year, how much does the boy grow? So let's figure out what he is in the 3rd year. Well, that's 3 times 3 plus 28.6. Notice the only thing that has changed is that. In other words, every single year he's going to grow 3 inches between the ages of 2 and 5. That will equal 9 plus 28. So that'll be 37.6. Well, what did he grow between years 2 and 3? He grew
3 inches.
3 inches. And so you could always do it this way. It's just that's a little harder, takes a little longer, a little more math involved, but it doesn't require you to really know what slope means or know that that's a linear equation. So understand that there's lots of ways to do these problems. You don't have to understand math in just any specific way to get a problem right. You just have to figure out a way to do it. When I did it this second way, I didn't know what slope meant, didn't know what y-intercept meant. I just figured out the difference in his height from age 2 to age 3. And it was 3 inches. Well, that means his average estimated increase per year is going to be 3 inches.
Okay.
Okay. So, stop there. Next time we'll start with 7, which...
I thought I had an hour.
I'm sorry?
Did I put an hour on there? Because I don't know if I did that or not.
My goodness, you did. Absolutely. I just forgot. I was thinking we started at 4, not at 5. Okay. So let's keep going. No, thank you for correcting me. I just lose memory as to when I started. Okay, so let's look at 7. Okay. Take a look at 7. Go ahead and read it. Look at the first few answers. Tell me, is this easy, medium, or hard?
Medium or hard?
Okay, I don't blame you for saying medium or hard. Most everybody would say hard. But it's question number 7. So how hard could it be? There must be something easy about it. Okay. So let me give you a hint. What if I told you that m equals a times b divided by c times p? Okay? And I said solve for p. What would you do? How do you solve that equation for p? You do have to be able to know how to do that. But once you figure out if you know how to do this, that gives you the solution to problem 7 all by itself. You don't actually have to know how to do any of that. None of that matters. Not a bit of it. Other than the last sentence that says solve it for p. Okay? So this problem teaches you a couple things. First of all, the people that make the SAT are trying to fool you. They give you all of this information which is irrelevant to the problem. And yet they look at that. They tell you what M is, what P is, what R is, and what capital N is. And you don't need any of that. All you need to know is that this is of the form that I have circled. And you have to solve that for P. So how do you solve that equation for P? When you're solving an equation and you want the final answer to be this, then you have to get rid of everything that's on the right side of the equation, correct?
Mm-hmm.
Okay, how do I get rid of the C?
Do you multiply it?
Okay, so now all of a sudden I get this. Is that correct?
Yeah.
How do I get rid of the A and the B?
You multiply it?
What is the A and B currently doing?
It's...
Is it a multiplier or a divider?
The divider?
Oh, look at it. It's multiplying.
Oh. Oh, yeah.
A times B times P. Okay, so if it's currently a multiplier, then you have to do the inverse to get rid of it. You got to divide. So I got to divide both sides by AB.
Okay.
Okay, now the AB's cancel, and I'm left with P. P equals M times C divided by AB. So that's our answer. The only thing is that they've complicated it up by putting in that's our A, that is our B, and this is our C. Okay? So now, look at the answers. Which one matches this down here?
Would it be B?
Yeah. Notice the numerator is our denominator. It's C. And that's what we want. M times C. There's the M over there. So it's M times C. And then the coefficient is divided by A times B. Well, that was A, that was B, and that's what that is. So in reality, this was actually a pretty easy problem. In other words, as long as you could solve this for P, it's an easy problem. As long as you see it, that is the problem we're talking about. I don't care about all this complicated stuff. R over 1200, 1 plus R over 1200 to the n power. All of that's crazy complicated. There's people who might look at this problem and spend 15 minutes on it and not make any progress on it because they're looking at it in the wrong way. You have to see it for what it is.
Okay.
And the fact that they've moved the P to the left and the M to the right doesn't matter. You know that. In other words, it doesn't matter if my P is on the right at the end or on the left. They're always interchangeable as to which side you have it on the equation. Okay?
Okay.
All right. This is a great example of problems. It shows you that they're always trying to fool you. So you cannot always assume that information they're giving you is information you need. Look at all the information they give you in that paragraph, and we don't need any of it other than the final sentence. Which of the following gives P in terms of M, R, and N? That's the only part of that paragraph we need to know. Everything else is fake news. That's the first time I've ever used that term with this problem. But so, okay, let's go on. Eight is the next one. This is still, oh no, hold on. The first section was, oh, I apologize. The first section was no calculator.
Oh.
So all of these questions we've been answering, you could not use a calculator. They will have another section that has approximately 20 questions where you can use a calculator. And then they'll have some questions that are not multiple choice, but you fill in the answer into a grid. Okay? So you can't use a calculator here. But notice that none of the problems did we really need a calculator. The hardest calculation we had was 5 times 2, or 4 times 4, or 3 times 3, or 7 plus minus 8, or 3 plus 9. So you don't need a calculator on this test. You really don't. They're out of the 60 questions they're going to ask you, I would say that there's maybe 1 or 2 where the calculator helps. That's it.
Okay.
A lot of times the calculator will lead you astray, and it will put you in a point where the calculator doesn't give you the answer, whereas if you did it a different way, you'd get the answer. For example, you have 200, I'm going to make one up here just because I remember it from another class I did, and it's a good example of this. I think it is. You have 244 chairs that have to go in around 13 tables. How many chairs go at each table, and how many do you have left over? First of all, how many chairs go at each table? How do you do that?
Would you have to divide by...
Go ahead and use your calculator on this one. I'm trying to illustrate something unique and problematic with the calculator. So use your calculator. Yeah, you're right. You'd have to divide what?
244 by 13, and you have 18.
Exactly?
18.7.
That's a big difference. Because the question wasn't how many tables you'd need, but how many chairs would be left over. How many chairs are left over?
7.
No. That's 0.7. That's a decimal. That's not the remainder. The way to do this problem is manually do the long division. Okay? That gives me 1. That gives me 8. There's my remainder, 10. There's 10 chairs left over. So if I do this problem manually, it's really easy. It's whatever the remainder is. That's how many chairs are left over after you fill up 13 tables. So you could do part of it using your calculator, but unfortunately your calculator always gives you that 0.7. Now, are you aware that there's a key on your calculator that will convert these to fractions?
Yeah.
Do you know where it is?
Under math.
Can you take that number 18.7 and convert it to a proper fraction? Then it'll give you the remainder. It'll give you 18 and 10/13.
Hold on. 2, 4.
10 being the key number. It may convert it to a proper or an improper fraction. So it would give you some number of 13ths, and that wouldn't be any much more helpful. But
Okay.
there's a lot of times where you're going to want to convert a decimal to a fraction, because most of these questions, they don't really want to reward the person using the calculator. They just don't. They want you to not need a calculator, particularly under the non-calculator section.
Okay.
So using the calculator, they always give you the answer in decimal. Now, if you convert that, it may not even give you this, which is what you'd like, or excuse me, this, which is what you'd like. In other words, it may give you 267/13, which is not helpful at all. Okay? So I guess what I'm trying to say is the calculator can't always save you on these kind of problems, but particularly in the non-calculator section, it's definitely not going to save you because you can't use it. Although that problem that I just gave you would probably be in a calculator section. You would just have to figure out how to handle that 7/10. Now you could multiply the 7/10 times the number 13, and that would give you 10, which is the remaining chairs. So there is a way to use the calculator on that problem. It's just you kind of have to know how to take that decimal part and convert it to a fraction.
Okay.
All right, let's have a look at 8. And we're starting to get a little harder, but not really. 8's actually not hard. Now, so far, we've really not run into a problem that we could solve by back solving. And this one is not one either. There are specific problems that are far easier to solve by back solving. And when we get to them, I'll let you know. But in the meantime, just kind of assume this is not going to be picked numbers either. We've got an A and a B in the question, but we don't have any A's and B's in our answer. So immediately you should decide you got to solve this algebraically.
Okay. I'm confused.
Not so easy, huh?
No.
Solve that for A. Remember how you solve equations. You get rid of denominators, you get rid of parentheses. Got a denominator, I got to get rid of it.
Multiply?
Yeah, that B is a divider right now. So multiply both sides by B, and that'll get rid of it on the left side.
Okay.
So what's the right side become?
BA?
What am I multiplying both sides by?
A?
No, the denominator. In other words, I'm trying to solve for A. So I'm going to multiply by that denominator B. That's going to get rid of it. since I'm multiplying the left side by b, I got to multiply the right side by b. Now, that b cancels with that b, and I end up with a equals 2b. Okay? Now, that's critical. You've got to be able to solve simple equations. If you can't, then we need to spend a considerable amount of time going through simple equations. By simple ones, I mean not quadratics, simple linear equations. Whether they have 1, 2, or 3 variables. You got to know you get rid of parentheses, you get rid of denominators, you get rid of exponents, you combine like terms, so forth and so on. Okay? So, now we know that's true based on that. So let's take that expression, and any place we see A, let's substitute 2B. So what does this expression become?
4b divided by 2b.
Now simplify that.
Would that be 2?
There's your answer. In other words, all the variables canceled out, and we were left with a number. But the key is you got to be able to solve that for A. All right. There's only 4 answers on this. Okay, I guess. Let me scroll down a little bit. Writing room. Okay. You know how to do 9.
Yeah.
Okay. How are you going to do it?
I have to put, well, I'm going to
Go ahead and tell me step by step.
With each x and y, you put the numbers from A, B, C, or D, and then try to decide.
Okay, so you're going to solve this system by substitution or elimination?
Elimination.
Correct. But in order to solve it by elimination, you have to put everything in order. In other words, right now I got an x and a y, and this is a y and an x. So the first thing I want to do is, first of all, put both of them in standard format. Which means that is minus x plus 2y. Okay, now I'm ready to proceed. What am I going to do in order to eliminate a variable? That's why it's called elimination, because you're trying to eliminate one variable, and then you're going to be able to solve for the second one. Once you solve for the second one, you're going to be able to go back and solve for the first one. So how can I eliminate either x or y? Remember what my rules are. I can add these two equations, I can subtract these two equations, or I can multiply one of the equations by the same amount on both sides. If I add or subtract these two equations, a variable does not go away, correct?
Yeah.
What if I multiply equation number 2 by the number 3? Then here's what I have. Here's equation number 1 still. It doesn't change. But now multiply both sides of equation 2 by the number 3. What do you get for the new equation for 2? Multiplying by 3.
Okay. So you get negative 3x.
That's key. Notice that matches now. Now I'm going to be able to add these equations, and x is going to go away. Okay, what do you give for the y's?
6y
You need a sign in front of it.
plus.
That's not presumed. If you don't say it, I'm not writing it. Different from a leading term. A leading term, you don't have to say it. But if it's part of a polynomial or an expression, you got to say it. And what is this? You can't use your calculator.
Negative 57.
Good. Now what are you going to do? In other words, this is my new equations 1 and 2. And I could have multiplied either equation by any number I wanted as long as I do it to both sides. Okay? Well, now it looks a lot better because what can I do now to get rid of a variable?
Just go down the line. I mean, go down.
You add them. It's
Yeah.
not go down the line. It's you're adding those two equations. And when I add them, I'm going to add the x's, I'm going to add the y's, and I'm going to add the numbers. Okay? So, what do I get when I do that?
So you just get x, right? Y.
3x, hold on. 3x minus 3x is 0x. So those cancel. There's no x. I've eliminated x. That's why it's called elimination. That's what I was trying to do, was eliminate x.
Okay.
How many y's do you have?
10.
Now here I don't need the plus sign because there's only one term. It's not being combined with anything else. And how many numbers do I have?
34.
Add those two numbers. They're both negative.
23 plus a negative 80.
Okay. And remember, you can't use your calculator, so you've got to be able to do that by hand, at least on that level. They're not going to ask you much harder than that, but you got to be able to do that by hand. So what's y equal to?
Negative 8.
Okay. Now, if you were in math class, you would have had to solve for x and y.
Yeah.
And this looks like, their answers are x's and y's. So normally I would have to take my answer for y, I'd have to go back, substitute it into the equation, and then solve for x. But they give us a break here. What's my correct answer? And I've only solved for y.
3 and negative b, so it would be b.
It has to be. There's no other negative 8s. Now, had y come out to be negative 6, then I would have had to go and figure out what x was, because there's negative 6. But there's only one negative 8. So they give the people that recognize that a time break. In other words, instead of taking a minute and a half to solve this problem, you can do it in a minute. That's an extra 30 seconds that you get to use on some other problem. Very valuable. And you'd be amazed at how many problems they do that with, where they give you, if you attack the problem in the way you're supposed to attack it, you save time. So it's really worth knowing how you're supposed to attack some of these problems. And now we're getting into 10. So we're going to expect them to be a little more difficult. Let's do one more. Call it a day. This involves a couple concepts. Tell me if I said, what does g of a 4 equal? What are you going to do? How do you handle that? What's it mean to have a number in the parentheses?
Multiply.
It means that you go to your function, and wherever you see x, put in 4. That's all it means. It's that simple.
Okay.
So, what is g of 4 equal to?
A and then 4 squared plus 24.
Let's simplify that.
8.
No, it's
16.
not 8. It's 4 squared.
16.
So it's
Or 8.
16a. I put the number in front of the variable just because that's the more standard way. Okay. Now, tell me what g of minus 4 is equal to.
A and then negative 4 squared.
Do all that math. Tell me what the answer is.
Negative 16a plus 24.
Ah, it's not negative 16. What's negative 4 squared? Positive 16. Negative 4 times negative 4. Negative times a negative is a positive.
Okay.
So this is 16a plus 24. Ah, they're the same thing.
Mm-hmm.
And it tells you that g of 4 is 8. Therefore, what's g of minus 4?
8.
You got it. So the key thing here is that when you are given a function, and then they ask you what is g of some number, you take whatever is in that and you substitute it for x. What if they said this? What's that mean?
You would put x in for 1.
No, you'd put x plus 1 in for x.
Okay.
Okay, so that would be a times x plus 1 squared instead of x squared plus 24. So the rule that applies in all cases is whatever's in the parentheses, no matter whether it's a number, a variable, a complicated variable, you put it in wherever you see x. That's it. Simple as that. So
Okay.
that is the principle that is at play in problem 10. Is you have to know what to do with that and that. It's actually a pretty easy problem when you do it. You see they're both the same? Bingo. I would call this a medium problem.
Okay.
All right. Haley, I will let you go, and I will talk to you. Let's just verify our next time. Next Tuesday at 5.
Yes.
Okay, cool. Talk to you then.
Thank you.